Good evening, everyone. A very warm welcome to everyone on behalf of ISRO Space Tutor KIYE. I am Hansika, active student coordinator from Kalam Institute of Youth Excellence. I am delighted to be a host for second lecture of S Talks, Science and Technology Talks. In previous lecture, we initiated our lecture series with the esteemed Dr. S. Somanath sir, former chairman of Indian Space Research Organization, who delivered the lecture. Dr. Somanath sir shared insightful information, captivating the audience and positive response. His expertise and engaging presentation style made the session highly informative and inspiring. That was absolutely incredible. Students, educators, and institutions from across the country joined us, learned with us, and started with us. And one thing became very clear: curiosity for space and technology is limitless. We meet every Saturday, yes, every single Saturday. We come together to learn, to explore, and to grow. More connection, more consistency, and more impact. S Talks is not just lecture series. It's a platform, a community, and most importantly, a mission to ignite curiosity, to inspire innovation, and to shape the future of young minds. Our theme is Space is the Next Destination. Let's explore it together. S Talks. S means science and technology. It is an initiative dedicated to inspiring young minds towards space, aerospace, and futuristic technologies. Imagine learning from some of the brightest scientific minds every week. Think of being a part of a movement that builds the next generation of scientists and innovators. A year long online lecture series every Saturday. Yes, 6 p.m. to 7 p.m. 52 lectures, 52 speakers, 52 topics, 52 hours of knowledge and inspiration. This is not a just lecture series, it's a mission to ignite curiosity and shape the future. Here is what you gain from S Talks. Learn directly from top scientists and industry leaders. Explore careers in space, aerospace, and emerging technologies. Build communication and critical thinking skills, and earn certification after completing all sessions. Let's now take a quick look at short audio visual presentation that showcases the vision, achievements, and impact of KIYE. Now the video starts. Next, I would like to invite our passionate student coordinator, Miss Vaishnavi, to share her experience in KIYE. Miss Vaishnavi, please go ahead.
Thank you, Hansika. Good evening, respected dignitaries, distinguished guests, esteemed mentors, and dear friends. I'm sincerely grateful for the opportunity to share my thoughts with this April Assembly. My name is Sai Vaishnavi. I'm pursuing my PTech in Artificial Intelligence and Machine Learning. I'm presently in my second year of engineering. Today, I feel honored to share my experience with KIYE Foundation, an organization that has played a significant role in shaping my personal and professional growth. Before joining KIYE Foundation, I had interest and curiosity, but I lacked exposure to real world learning and leadership opportunities. KIYE Foundation provided me with a platform where learning goes beyond classrooms and textbooks. It helped me understand the importance of leadership, teamwork, and responsibility. I got the opportunity to be involved in organizing major events such as Vigyan Vaibhav and Kalam Space Convention. Through these events, I learned planning, coordination, communication, and time management. I also gained confidence by interacting with professional speakers and students. KYE helped me to overcome stage fear and self doubt. It encouraged me to take initiative and believe in my abilities. Every task assigned to me became a learning experience. Every challenge helped me grow stronger and more confident. What makes KY Foundation truly special is its vision to empower students and nurture young leaders. Today, I stand here as a more confident and focused individual with clarity about my goals and career. I'm deeply grateful to KY Foundation, my mentors, and my team for their constant support and guidance. Thank you, KY Foundation, for shaping my journey. Thank you all for giving me this opportunity. Thank you, Hansika, once again.
Thank you, Vaishnavi, for your dedication towards KIYE and sharing your experience with us. Now comes the highlight of today's event, the moment we all have been waiting for. I'm honored to speak about an inspiring personality, Dr. B. Chiranjeevi Phanindra, sir, who has made remarkable contributions to India's space journey and is now shaping the future of space technology. With over 14 years of experience at the prestigious Indian Space Research Organization, he has played a vital role in some of the nation's most important missiles, including Chandrayaan and Gaganyaan. His journey reflects dedication, intelligence, and a deep passion for science and innovation. Having completed a master's degree from IIT Kanpur and a PhD from IIT Madras, his academic foundation is awe-inspiring as his professional achievements. During his time at ISRO, he served in several key roles, including scientist or engineer, deputy project director, and head of division. As Deputy Project Director for Gaganyaan, he contributed significantly to India's dream of sending humans into space. His work included designing space debris shields and advanced thermal systems, which are crucial for astronaut safety. Not only limited to India, he represented the country on global platforms, collaborating with international space agencies like CNES and ESA. He also addressed one of the most critical challenges in space today, space debris at international firms. Currently, he is the founder and CEO of Cosmoserve Space, a startup based in Hyderabad. Here, he is developing autonomous robotic spacecraft to tackle the growing problem in space. Providing the innovation never stops. His journey teaches us with the knowledge, hard work, and vision. We can not only reach the stars but also protect the future of space exploration. Let us take inspiration from such leaders who are not just dreaming but also building the future. We are deeply privileged to have you with us today, sir. Sir, the virtual stage is all yours.
Thank you. Thank you for the introduction. So how do you want me to proceed? I'll start with the presentation, and then I would like to understand how the interaction with the students will be. Like if they ask questions, many people, I understand they are watching out of YouTube. So how would that questions be coming to me?
Sir, I will be a host for today's session, sir. From the YouTube live chat, we'll be addressing those questions and we'll be asking you, sir. After your
so you will be picking the questions from there and asking me, right?
Yes, sir.
Okay, all right. Okay.
Thank you,
So
sir.
usually how I do is I do an interactive session. Like while I was talking, I'll ask some questions and I need feedback. In this format, it looks like it is difficult. So what I'll do is I'll finish my 30 minutes talk, and while my talk is there, any questions are there, you please note down, and then yeah, you can ask those questions during the end. That also will work.
Okay, sir. Definitely, sir.
Okay, okay, okay. Let's start then. Yeah, you can see the screen, right?
Yes, sir.
Yeah. So we are cleaning the Earth's orbit. Why do we need to clean the Earth's orbit first of all? Is it so much junk out there? And if we are not cleaning the Earth's orbit, what is going to happen? Let's understand all of these in this today's talk. Uh, you know, we think that there is a lot of junk in space, and then even if the junk is going and hitting an object in space or a satellite in space, how does it matter? It's a big deal for us, right? There is a this junk is uh, it may damage a satellite, but it's okay, another satellite we can send. What is the big deal out of it? But if that satellite is going to give warning signs to you during a flood situation, and that satellite gets damaged using because of the space debris, so the lives on earth are getting affected because of the space debris. So that serious is the situation of space debris now. Unless we are clearing the space, we can't space the way we are using now. It's very important that we have to understand how big is the problem and then how to solve this problem before that problem really hurts people on earth. That's what we do. And to give you some statistics, last 7 decades, that means last 70 years, the first launch, when it was happened, 1957, Sputnik was sent to space. From then, now it is 2026, 70 years. In 70 years, the entire world has launched about 20,000 objects into space. And now we are thinking of launching 1 million satellites, that is 10 lakh satellites in just 10 years. 70 years, what has been launched is only 20,000. And next 10 years, we are going to launch 10 lakh satellites into space. So that the population in space is going to be large and exponentially growing. And this is creating the greater threat to the operational satellites. Out of these 20,000 objects which were launched to space, there were some incidents, there were some anomalous events or some collisions. Uh, these are reported as 650 in numbers. So these created 50,000 large objects. Large, what I mean is anything about 10 centimeters, and then 1 million, 140 million small objects. So in out of all these 50,000 large objects and 140 million small objects, the operational satellites is only 12,000. So there are 12,000 satellites, but if you see surrounding them, there are 50,000 large objects and 140 million small objects. That is 14 crore small objects. The operational satellites are now dodging through these debris. Debris is highly uncontrolled. Go near an object, and then you need to actually escape that. Otherwise, it will come and hit you. And when it comes and hit your operational satellite, that also will create thousands of more debris. So let's see how what happens if satellites collide in space. So this video shows collision of Iridium satellite and Cosmos satellite. Iridium is a US satellite which is operational, and Cosmos is a non-operational, which is a dead satellite from Russia. Both collided in space in 2009. That created thousands of fragments, and now these fragments just don't stay there. They will be spread across orbits. You can see now they'll be spread across different orbits into space. right? So when these debris particles or the fragments spread across different orbits, they pose greater threat to the existing satellites or the operational satellites. Can you imagine how large the impact can be? Do you just imagine F1 race car uh, going at its highest velocity and impacting onto a stationary wall? Just imagine that situation. So that kind of kinetic energy or the impact energy is generated when a small aluminum ball goes and impact on a satellite. Why is it so? Because the impact energy again is or the kinetic energy is a function of mass and velocity square. So though the mass of the aluminum particle is low, but it is a function of velocity square. The velocities in space are in the order of 28,000 kilometers per hour. And the speed limits on the roads are 100 kilometers per hour or 80 kilometers per hour. And I am talking about 28,000 kilometers per hour. So that kind of velocities, these objects will float in space. And if it is head-on collision, so it can be double the velocity. The impact velocities will be double, which is in the order of 56,000 kilometers per hour. So that kind of energy is there, even if it is a small aluminum ball or a small pearl or any small fragment in space that can create this kind of damage in space. So you can see here on the right side, you have a small 7 ball has created this big crater inside a thick aluminum block. So this is a kind of experiment which was conducted in ground in one of the test facilities. So to show what is the impact that can be generated when a small aluminum ball impacts onto a thick block. But these thick blocks can't be carried to space. So the spacecraft walls are made of thin walls or high strength materials, but they are not of these thick blocks. So you can understand if a aluminum ball comes and impacts this thin wall in satellite, what kind of damage that can create. So the problem lies, the major problem there in space is the small debris. But the source of small debris is the larger pieces when they collide and they become small debris. So we need to address the problem. That means we need to right away address the source. So what we are doing is we are addressing the source by removing the bigger objects from space. So these are some of the impacts occurred on International Space Station and Space Shuttle. So in around 2024, 2025, in a 6 months period, there were 3 fluid leaks from the International Space Station. The moment there is a leak from the fluid leak from the space station, they need to close that wall. That means the performance of that particular module will come down. That means if they have to live with earlier, if they have to live at 23 degrees centigrade, now that module will operate at 25 degrees centigrade, higher temperature. So the astronauts and the equipment, everything have to adapt to these new temperatures till another cargo mission comes and then replaces that fuel or the coolant which is flowing through these radiators. So this kind of impacts are happening. And then recently, one of the Chinese module has to be vacated because of because of the debris impact. This all the human space flight missions will happen at an altitude of about 400 kilometers. 400 kilometers is known to be the safest orbit, and we call it as a human space flight orbit because the space debris is low. Other missions will not happen, only the human spaceflight missions will happen. The regular satellites will be launched 500 kilometers and above. Nothing will be launched at 400 kilometers. So we expect the debris to be less. Even in this safe orbit, there are these kind of impacts. So that means you can understand what kind of problem we are talking about and how important and how serious the problem is. So I talked about the problem. Now you all got the feel of problem, right? Now let's talk about the solutions. So what do you do? How do you mitigate traffic on road? You have on road, what you do is you put the traffic signal. Uh, you will ensure that one line, the cars in one line will stop, so that the cars from the other line or the vehicles from the other line will pass by. uh, but can we do that on space? We can't do that because you can't stop a satellite in space. The moment you reduce the velocity of a satellite, the centripetal force, the gravitational force, will attract the satellite towards the Earth. So why the satellite remains in space? Because it is injected into orbit at a high velocity, and that high velocity has created some kind of centrifugal force, a force acting outward, and which is compensated, or which is balanced by the gravitational force or the centripetal force. When these two forces are matching, the satellite will remain in that orbit. It will continue to remain in that orbit. But as the moment you reduce the velocity of that satellite, that means the gravitational force will be dominant, and then the satellite will be coming closer to the Earth. So you can't stop some satellite. So we have to have some other solution. What do you do for air traffic management? So there is already an aircraft on the runway, and then the incoming aircraft or inbound aircraft has to land on that runway. So what do the air traffic management will do? The air traffic management will ask the aircraft to go around. So take one more round before this aircraft on the runway takes off. So that is the management which is done in air. Can we take the satellites? Can we ask the satellites to go around? We can't do that as well. So in space, we have a different mechanism. We call them as collision avoidance maneuvers, and we can see how this happens. We predict that some debris is going to come and impact our satellite after a month or so, and we predict that they will come closer within a radius of 1 kilometer or so. If that is happening, then we fire our thrusters, we move the path so that the debris will pass by, and we bring back the satellite to its original position, because it has to perform its activities in that particular orbit, right? So that means we need to burn more fuel to do this collision avoidance maneuver. So the more and more debris, the more and more maneuvers, and more and more fuel which you are burning to avoid all these collisions in space. So it has got its own challenges. These challenges I want to highlight because when you people want to go pick some career or pick some research topics, these challenges are very important to understand. What are the challenges currently the industry is facing? So you can pick these topics, you can research on them, and then you can find your own solutions. So this can become a path for your career or a path for your research. So I want to highlight on these challenges after every topic. So one is, you understand, right? There is an exponential growth of satellites. So either we need to reduce the satellites which are being sent to space, or for reducing that, you have to enhance the ability of the existing satellites. If the satellite's lifetime is only 5 years, you ensure that the lifetime of that satellite is increasing, so that the requirement of new satellites being sent to space is less. So that is one way of doing. You can think multiple other ways as well. And these collision avoidance maneuvers are currently manually operated. You estimate that there is going to be an impact, and then you upload a code onto the satellite, so that the satellite will do these maneuvers at a particular moment. But the more and more impacts are happening, then the manual ability is also limited. So this can't be done at a high scale. We need to do something else. And the orbit determination, the debris orbit is determined using the radars or ground stations, which will be looking up in space, and then they'll be detecting the orbit's different parameters, right? And these parameters are not that much accurate. We need to increase the accuracy of that. So as we come closer to the incident or the activity, this what I mean to say is, the accuracy will improve, but you can't wait till they both come closer, right? You need to do this activity, prevent this activity much earlier. So there is a trade-off between the time when you do this activity and the uncertainty trade-offs. So, and yeah, non-cooperative and non-maneuverable objects. There are multiple objects which are non-cooperative in space, like the space debris. It is not having its own control system or not having its own management system. So if there is a collision between, if there is a conjunction estimated between the operational satellite and a dead satellite, so the operational satellite only has to move, right? But if there is a collision conjunction chances between two dead objects, nothing can be done. You can't control any of these satellites. One of them will go and bump into the other, and then that creates thousands of fragments, and each one of them is a threat now. So that is a bigger challenge. So you need, or the one of the solutions is you need to go before this happens and pick one of those dead objects and remove it from space. So the solution for that is active debris removal. There are different solutions available by different companies in the globe. One is providing a magnetic latching plate onto the customer satellite. So before the customer satellite becomes dead in space, before the customer satellite even being launched to space, this magnetic docking plate is attached to the satellite. So after going to space and after the satellite is dead in space, that is when this robotic spacecraft will come using its robotic arm, go and latch to the satellite and then pull it down. So that's how it can be done. But this can't be scaled to the satellites which are not carrying these docking plates, or the dead objects already there in space, or the debris which is already there in space. So there is one limitation in this kind of approach. And they'll capture it, right? But they have these robotic tentacles have got limited degrees of freedom. So the size and shape of the object being captured is also limited. SARA satellite technology, they are putting net around a satellite and then pulling it down. So that is one of the challenge. And while they are placing this net around a satellite, secondary capturing a debris in space, you can't create more debris according to the regulations. So that is one of the challenge. Other techniques involve the previous slide. We have seen the contact techniques, like we go physically touch the object and remove. And in this slide highlights methods of non-contact removal of debris in space. One is ion beam shepherd. They aim some ion beam onto the satellite, and then that pushes the satellite down, because that is reducing the velocity of the dead object or the dead satellite. When the velocity is reduced, what happens? You already know that, right? The gravitational force is dominant. That's why it will come down. And there are ground-based lasers that will also focus onto the satellite, and then that creates some kind of cloud around a satellite, and that cloud creates higher drag, and that drag reduces the velocity of the satellite. So that's how it will come down. And space-based lasers, whatever the ground-based, now we can put those lasers onto the satellites, and still we'll be able to remove the dead objects from space. These are some of these techniques. And we are doing it something different way. So let's see a small video. We have this robotic spacecraft with soft robotic arms, four of them independently controlled, like this Venus flytrap, you know, right? When insect enters the Venus flytrap, it closes its lobes. So something similar to that, we are developing this. These are flexible. They'll go around the object, hug the object tightly, pull it down very close to atmosphere, leave it and give a kick towards the atmosphere or the Earth surface. And the re-entry temperatures are so high that the satellite will completely disintegrate in the atmosphere. And we'll proceed back to the next target. So the number of times we can remove the dead objects from space depends on the fuel which we are carrying. So to enhance that capability, we are also placing a mother craft, a refueling depot in space. So the refueling depot will refuel the smaller craft, the reviver craft, and reviver craft will proceed back to the next target. And if it is a fragmented object, we use all four robotic arms or pedals so that it is not escaping from any other direction. So what are the challenges here in bringing down the satellites very close to atmosphere? When you are actually bringing down very close to atmosphere, that means they are burning in the atmosphere. They are creating some kind of metal oxides in atmosphere, which is very dangerous. So we don't have any other option currently. Some of the other options will be futuristic options, which I think the next generations like you only will be able to do that. For us, the only option available is bringing to Earth's atmosphere. We can't push them up because any satellite which is at 1,000 kilometers, if you have to push them up, there are satellites up to 36,000 kilometers. You can't push them to 2,000, 3,000. So there are satellites at 20,000, there are satellites at 36,000. But if a satellite is there at 36,000, so what we do is we push them to a graveyard orbit, which is at 40,000 kilometers, much higher. We push them there. But the satellites which are very close to atmosphere, I think we have only this is the solution. So that's what we are doing. But there are other ways for doing this, and that is the most futuristic, and we are also working on that. So that is the servicing. So we, instead of you bringing down the satellites, you service them in space so that the life can be extended, or you can repair the satellites in space, or you can extract the materials in space, then melt them there, and then 3D print a new satellite in space. So that is the futuristic technology, and that's where the world is moving towards, and that is where you people, young people, have to take up the challenges and bring new and more new solutions, right? Let's see how servicing will work. So this is refueling. This is building a satellite by changing the components, attaching new surfaces onto the satellite. And yeah, this is done. I think this animation is done by Thales Alenia Space, one of the prominent space industry in Italy. So we have refueling depots, space manufacturing, like I said, melt the materials and 3D print them and make structures in space. So these are all the futuristic technologies. And the challenges are satellites are not designed for servicing. What does it mean? If there is a component, a battery failed inside a satellite, you can't access that. So because it's all covered with the walls, right? Unless you have access to that particular component, you'll not be able to repair. So the futuristic satellites should be built in such a way that any service satellite can come and replace a component or do some servicing on the satellites. So that is one of the futuristic things. And second is standardization. Like everyone's of your car will have a hook in the front, right? So because that is where the entire load is transferred of your car. Because if you can put a A towing van can come and hook to that point and it can pull your car. So that is a standard hook. Such kind of standard things that should be available even in space. For doing the refueling, any servicer can come and do the refueling. It should not be only made for one company so that that company only will come and do. So a lot of standardization has to happen in space. And there are these non-cooperative and tumbling satellites. So it's very difficult to reduce the tumbling rates in space. So you need to use special materials, special kind of flaps to reduce the tumbling rates. And once the tumbling rates are reduced, that is when you will be able to capture them and dock to them and do some activities. And space is one of the harshest environments. There is vacuum, that is no air, no pressure, and there are temperatures are very extreme. Uh, the sun side, because there is no atmosphere, the face facing the sun, the surface facing the sun can go as high as 80 degrees centigrade, and the surface facing away from sun, that is facing the deep space, can go as low as minus 40 degrees centigrade. So that means you have a small cube. One face will be plus 80 degrees centigrade, another face is minus 80 degrees centigrade, right? So that kind of temperature gradients are there. So these temperature gradients are very, very difficult to handle. And you have the radiation effects in space. So all that is creating threat to the sensing, pose estimation, sensors, and many other things like that. So we need to really understand the space environment and design solutions for space environment. And the launch cost of satellites is really high. So that means whatever you design for space, three things you have to keep in mind. One is the volume should be limited, the mass should be limited, and the power requirement should be limited. So you can't just build bigger structures, more power thirsty structures, or a big volume structures, right? You need to really take care of these three parameters: volume, mass, and power. And how the robotics arms are activated on ground, because on ground gravity is there, and in space the gravity is not there. So you estimate that you need to give certain force to lift your arm. The same force you give in space, the arm will move at a higher rate, or it can move to a different distance, right? Because the gravity is not there, that component is not there. You need to really study that, understand that, design the systems for microgravity or no gravity condition. So these are some of the challenges, and all these challenges I put in front of you, and all the problems I put in front of you, and there is one big solution. I want to reveal that solution. Are you ready? I want to reveal one big solution which can change everything, every of these things, and then make space clear, make space sustainable for the future generations. Are you ready for that one solution? That solution is you, right? You are the guys who can you can solve these challenges. You are the guys who you can solve these problems. And you are the guys who can create a sustainable space so that your children, your grandchildren will be able to use space. So you are very important in this entire ecosystem. Yeah, so earlier I used to list down all the websites. Now I'm not listing down the websites, but I'm just asking you to go through one of these Gen AIs so that whatever you have the questions you can ask, but always be cautious. Whatever these ChatGPT, Gemini, Cloud they are giving, don't trust them 100%. You need to take the references. Even in ChatGPT, when you type something, you get some solution, right? You get some answer, and that answer will have a reference. So go to that reference. If it is a research paper, try to read that research paper and get your own inference on the topic instead of you believing entirely what ChatGPT is giving. If ChatGPT can give everything, you are not required, right? So your importance is there only when you are enhancing your capabilities with ChatGPT or Gemini. You're not replaceable by all this artificial intelligence. So that's all from my side. Thank you very much, and thanks Nareshji for giving me this opportunity, and happy to answer any of your questions.
Thank you, sir, for the deep insight and inspiring talk. Your words have inspired us that age is no barrier to innovation and that we too can take bold steps toward for building something impactful. Your words add value to the young mind's future. Now I request our guest, Dr. B. Chiranjeevi Phanindra, sir, to take few questions from students and our audience. We now open the floor for a short Q&A session. If you have questions, please drop them in the live YouTube chat and we will address few questions right now. Sir, there is a question from one of our participants named Jayant. Jayant, please go ahead.
Good evening, sir. This is Jayant from KIYE Student Coordinator. Sir, I have a small question. Sir, how do we track space debris in the space, sir?
Yeah, so there are different agencies doing that. One is SSN Space Surveillance Network of USA, and the new companies like Leo Labs, Tigandra, all these companies. What they do is they monitor the space by using some sensors. We have ground stations which can continuously monitor the space. So whenever there is an object launched to space, that is, you are putting a satellite, a student satellite, you are putting into space, you need to register with United Nations Office of Outer Space Activities. So when you register this object, that means this information will be going to all these agencies. From then they will give an identification number for this object. And from there, they will start observing it regularly. So when they observe this object regularly, they know that it is going in this direction. Mostly it will go a particular path and there will be some deviations over the period of time. So all that updates will happen in these softwares. And there is a large database for that. Now, if two objects collides in space, that creates thousands of objects. These are not registered, right? Because you don't know that this collision is happening. So in that situations also will be monitored from ground, and then they'll trace the particles coming out of that collision location, and they will identify, they will give new numbers for them. So that is called cataloging. So about 50,000 objects are there which are cataloged in space now.
Thank you, sir.
There is another question from one of our another participant, sir. Sai Vaishnavi, please go ahead.
Good evening, sir.
Good evening.
Sir, I have a question that what is a transporter in a satellite, sir?
Transponder.
Yes, sir.
Right,
Transporter.
for your communications, you need to have a transmitter and a receiver, right? For if you're communicating from one place to other place, there should be a transmitter which will generate these electronic waves, and then is a receiver, right, which will receive the signals. So the transponder is one equipment which is there in space on communication satellites, not on all satellites. So the communication satellites will carry these transponders. So these transponders will have a limited capacity. So based on that limited capacity and limited frequency or the frequency of operation, so you can send signals from ground to these transponders, and then that will again communicate across the globe or wherever it is having a footprint. Those are the transponders.
Thank you, sir.
Sir, there is another question from YouTube audience, sir, named
Yeah.
Ravina. How does remote sensing helps in debris detection?
Remote sensing helps on direct detection. Can you repeat this once?
How does remote sensing helps in debris detection?
Debris detection. Remote sensing is for sensing the earth, right? So that is remotely you are sensing the earth. That's why it is called remote sensing. The cameras are always focused to earth, or the synthetic aperture radars we call SAR. These will be focusing onto the earth and then giving the data on earth. Like you want to see where the water flow is more and where you need to divert. You need to understand what is the crop growth, or you need to understand where more fishes are concentrated in the ocean. So it has got different applications. But for space debris detection, you can't use remote sensing satellites, but you can use some satellites with sensors which are focusing towards the space. So these sensors will detect the objects in space. So such kind of satellites are also being launched into space now.
Sir, can I extend the questions from live YouTube?
Yes, 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 yes.
Sir, Shritan named, how long your satellites provide service?
So yeah, uh, how long do they provide services? As long as they carry the fuel, they have the enough fuel to do that, right? So that's why we are also carrying this mother craft, a refueling depot in space, which is having lot of fuel, about 3000 kgs of fuel. And this fuel will be continuously pumped into the smaller spacecraft, and smaller spacecraft will be able to do. So typical timelines are like 5 years, and then the pair of satellites will be able to remove nearly 100 dead objects from space.
What kind of resources do you satellite use on other than solar, sir?
So currently, the only source of power in space is solar. So people are talking of nuclear energy and other stuff. But majority of the satellites currently use only the solar power. So we also use only solar power, but we use also chemical propulsion, right? So these chemicals, the fuel and oxidizer, when we mix and then send through the thrusters, that will give some kind of energy so that the satellite will be moving forward, or we can break the satellite's velocity using this chemical propulsion. So fuel is one portion, one energy source, and there are batteries which are again recharged using the solar power. So solar power is one of the power source, or the major power source.
What inspired you to work in this field, sir?
So I was part of ISRO, right? I was there for 14 years. I was representing India on a global platform for space debris mitigation, which is called IADC, Interagency Space Debris Coordination Committee. So that is a committee of 13 space agencies. Every year we come together, NASA, ESA, Roscosmos, KENES, all these are space agencies of different countries. So every year we come together, we discuss about the problem, and we understand which direction the problem is going and what are the solutions available, what needs to be done more. So as an insider, I understand that this is going to be a large problem, and the solutions available are very much limited, and the existing solutions are also having some technical challenges. So we need to create a really a big impact in this, not a small change. We need to create a big impact in this. So that's how I started this journey. And yeah, we are building solutions for space removal now.
That was an inspiring journey for us, sir. Sir,
Thank you.
another question from Charan, sir. Sir, can satellite run purely on electric source?
Yeah. So there is electrical propulsion, which is again, which will again use solar power. So that will create some kind of thrust through ions. So only through electrical also satellite can be powered, or solar power.
Can space debris be reused or recycled, sir?
Yes, yes, that's what I have shown in servicing, right? So space debris reuse and or we can service the existing dead satellites. So that is the future, and that is where the generations, next generations like you, have to pick that as one of your areas and then start working.
Another question from live YouTube chat. How much it is expensive to remove space debris, sir?
So it is quite expensive now. Let us say you need to remove one 300 kg dead satellite from space. That would be anywhere from 45 crores to 90 crores currently, which is really, really costly. So that I need to bring it down much, much lower so that many people can afford these services. So that is what primarily we are working on.
Another question, sir. Can we design satellites that don't become debris?
Debris that don't become debris, right? That is the question, right?
Yes, sir.
Yeah, yeah. So that's what I have discussed that part also. So how a satellite will become debris? One is its fuel is over. So when there is a collision avoidance maneuver, it can't do its maneuvers. So because its fuel is over. So if fuel is over, you should do refueling. So if the satellite is designed for refueling, thus still you can extend the life of that satellite. You can ensure that the satellite will never be dead, eternal. And the second is some component fails inside the satellite, like a battery fails inside a satellite or an electronic package fails inside a satellite. So then also the satellite is dead. So you need to do servicing, replace that battery with another battery. So then also the life of the satellite can be extended and you can make the satellite will not be dead in space. So these are some of the solutions which we all need to work together.
Another question from Vaishnavi, ninth grade Srinidhi School, sir. Which type of space debris is very hard to detect?
So anything less than 10 centimeters, it is very hard to detect because when we are watching from ground, the distance of these objects are like 400 kilometers and away, right? So it is very hard to detect any object less than 10 centimeters. There are some companies who are doing up to 1 centimeter, but this millimeter size particles, it's very difficult to detect. So we don't know. We are telling that 14 crores small objects are there in space. So that is a statistical estimation that you estimate that this collision created this many objects, so it would have been this much population, right? It is not exact number. So that is, these are some of the objects can't be detected in space.
Another question, sir. How can you detect that it is a satellite, not an asteroid?
Yeah, and so I said, right, whenever you launch a satellite into space, you need to register that object into object, and then with United Nations. So then they will create a number, unique number for your satellite, and that will be given to all the operators. So that's how you know that these are satellites. That is one way of doing things. Other way is you also observe the object. So when you're observing the object, you clearly see that it is having solar panels or how the shape, structure of the object. Then you can understand whether it is a rocky body or a satellite. So satellite will have some reflecting surfaces. We cover it with multi-layer insulation and then solar panels. So all that are reflecting surfaces. If it is a rocky surfaces, no, right? And rocky surface is an irregular object also. So that's how we identify whether it is an asteroid or a satellite.
Another question, sir. What is your advice for school students and engineering students to choose space as their career?
I think space is the next frontier. So there are so many things which are coming up, but then space is one thing which has got a lot of future. And people are talking of going to Mars, going to Moon, and if they have to really go cross the Earth's barrier, then they have to cross the all the orbits. So ensure that there is nothing coming and impacting onto your rocket while you are traveling that distances. So space debris is one important problem as well. So space, you every day day-to-day life, you are using GPS when you are traveling from one place to other place. You are making video calls. Space became like everything now. Just put your mobile phone on airplane mode and try to live one day. You will understand what is the significance of space. Just put mobile phone and just be with your surroundings. No TV, nothing. Just be with your parents, be with your friends, talk to them. Then that day you realize how much we are using space, and if space is not there, what is the kind of effect, right? I hope I answered the question.
Yes, sir. Another question, sir. Can you please suggest some courses related to space when we want to take space as their own career?
So time to time, there will be some announcements from ISRO. You can have a look on those opportunities, then do those courses. Otherwise, yeah, don't wait for. There are so many other ways of doing courses, right? Like NPTEL. That is being conducted. NPTEL courses are there which are freely available, and there are courses from universities like Stanford, and so these are all available in the internet, and then you can start doing it. Again, you need to pick a particular topic. Space itself is like a vast topic, right? There is no space as one of the engineering curriculum. Space consists of mechanical, electronics, civil, everything. Every branch will work together to build a space system, right? So you need to really pick a subject. If you want to do propulsion, you need to pick that. If you want to do some avionics, you need to pick that, and then start doing courses in that. But for general awareness, you should start one course which will give an overview of how the space activities, how the rockets are built, or how the satellites are built. But once you understand that, you need to really go deep in one particular topic. That is when your skill set will be improved.
How Cosmoserve is going to play a role in Indian space industry, sir?
So space debris is really big problem in the globe. So we are building solutions from India to the globe. So that will create a great economy, and that will create a lot of employment in India. So that is what we are trying to do: build solutions from India to the globe.
Another question from live YouTube chat, sir. Vinay, an astronautical engineer, what are the main design challenges in building a debris removal satellite?
So every solution you are building, every product you are building, it will have its own challenges. You really have to understand when you're building a product, you have certain goals, certain objectives. You will build for that, right? While you're building, you will discover that there are some more challenges. So you have to solve for those challenges, and then finally, while you are doing it, some unknowns also will come. You have to be prepared and then solve all these problems. But in primary challenges for designing any space systems is you need to design a system within a given volume, within a given mass, and within a given power budget. So that is the primary challenge. So that we need to keep in mind.
Sir, do you use simulations or software models to study debris movement?
Yeah. We use, and then there are like I said, right, SSN, Space Surveillance Network, Leo Labs. So they all have this database available, and then they provide the software or the database to us on in a software. So we can see, we can monitor how the systems are there, how the debris is moving in space.
Sir, this is a question from Varalakshmi. What are the benefits of rocket engineering, sir?
What are the benefits?
Yes, sir.
Rocket engineering. Rocket engineering itself is like very, uh, they call it rocket science, right? Because millions of or lakhs of components should function simultaneously in a given time. If they all have to function at that together simultaneously, then the rocket will go successfully. If one component fails, it is really, I mean, it is going to be a catastrophic failure. So rocket science itself is like very hard. And if you are able to solve that rocket science, if you are able to understand rocket science and then build rocket systems, you can build anything in the world. I'll show you a small, uh, I'll show you a web page. You can understand. You can see that, right? So this link I'll share with you people. You can check it out later. But then you can see the screen now.
Yes, sir.
Okay. So, so these are the objects currently in space. You can see. So I'll remove all the space junk. It's only the active satellites. So these are the active satellites. Now let me add the inactive satellites. That means the dead satellites. So these are the dead satellites. Now let me add the uncategorized. That means you don't know. It may be a military satellite or something. So that is this. And let me add the rocket body. The rocket bodies, upper stage of the rocket bodies, they'll continue to be there. They are all dead bodies in space. So this is the rocket bodies. And let me add the debris, the fragments which are created by collisions. So this is the debris. So that kind of debris population is there in space, right? So you can play around with this software. You can understand how the space debris is. Yeah.
Last question from Vaishnavi sir. Do we have astrophysics in India which deals with time travel or wormhole or black hole?
I'm not completely aware of this, but there are some institutes working on this astrophysics. One is PRL, Physics Research Laboratory under Department of Space, and TAFR, Tata Institute of Fundamental Research. I think, yeah, you can see their websites and see what they are dealing with, but I'm not very much sure of this.
Thank you so much, sir, for encouraging young minds by giving answers to their questions. And I also thank each and everyone who showed interest in today's session by asking questions. As we come to the close of this remarkable session, I invite Mr. Jain to present the vote of thanks. Mr. Jain, over to you.
Respected dignitaries, teachers, and my dear friends and students, a very good evening to everyone present here. Myself, Jayant, student coordinator from KIYE, and I feel extremely honored to stand before you to deliver the vote of thanks. On behalf of the KIYE Foundation, along with the entire organizing team of STOC's lecture series, first and foremost, I would like to express our heartfelt gratitude to Dr. Chiranjeevi Phanindra sir for his valuable presence and inspiring words. Sir, your insights about space, science, and technology have truly motivated all of us. Your journey and achievements are a great source of inspiration for students like us. Sir, your words have truly ignited scientific curiosity among our students and encouraged many dreamers in the fields of space technologies. We are deeply grateful for your time and effort in sharing your knowledge and experience. Your knowledge and achievements have encouraged us to big and aim high. I extend my sincere thanks to our organizers for arranging the wonderful session. Special thanks to our teachers and coordinators for their continuous support and guidance. I also thank all the participants for the active involvement and enthusiasm. Your presence made this event more meaningful and success. We are thankful to everyone who worked behind the scene and make the program a grand success. Once again, thank you, Dr. Chiranjeevi Phanindra sir, for your inspiring young minds like us. We hope to carry forward your words and contribute to the field of science and space technologies. This session has been a powerful reminder that space is the next destination and we must explore it together. Before I conclude, I warmly invite everyone to stay connected with us upcoming initiatives. Join our WhatsApp channel, subscribe to our YouTube channel, follow us on Instagram, visit our official website for future. Let us carry forward the legacy of Stokes and Dr. APJ Abdul Kalam ji by narrating scientific temper, encouraging innovation, and building a knowledge driven future. Thank you once again. Jai Hind.
Thank you. Thank you very much. Thank you to all student coordinators and Naresh ji for giving me this opportunity.
Thank you, Mr. Jayant, for those wonderful words of gratitude. On behalf of everyone, I extend my heartfelt gratitude to Dr. Chiranjeevi Phanindra sir for joining us today. Your inspiring words and insights into space have truly set a powerful tone for this series. It has been an absolute honor for me to host this session in your presence, sir. We sincerely thank you for motivating young minds to dream big and reach for the stars. And I also thank each and everyone who joined us. Thank you for being a part of Lecture 2 of S-Talks. Let's continue this journey together as we explore new things in science and space. Let's stay connected, stay curious, and keep reaching for the stars because truly, space is the next destination. Let's explore it together. Have a wonderful evening, everyone. Jai Hind.
Thank you. Jai Hind. Bye bye.